Okay, here we go again, boys and girls. Let me scroll up. This is assignment 10B. So again, this is, you're trying to determine a difference between, in this case, the typing speed of a new keyboard and a regular keyboard using a distribution curve. Okay, so let's remind ourselves of the different things that we have here. We're going to establish a difference. A difference is x1 minus x2, or in calculator speak, list 1 minus list 2. All right, we're going to have to find an average of that, which is you add them up. So you add up all those differences, which again is a list, and you divide by the number of numbers. Okay, after we establish those things, then we are going to be able to accomplish our standard deviation. The standard deviation is going to be the sum, I want to write x, d minus d bar, closed squared closed, divided by n minus 1, square rooted. All right, so that will get you your standard deviation. Sample test statistic t, which is going to be d bar of s divided by the root of n. And then there's the degree of freedom, which is very easy, is n minus 1. And then from there on out, it's drawing your curve and making some determinations from your material. Okay, so how I begin this is I begin with making x1 my list 1, make x2 my list 2. Okay, and then from there we are going to be able to discover our difference d, and that I store as list 3. It's going to be a list, and so that's going to be stored as list 3. So ultimately d is going to be list 3. And then I'm going to plug and chug into that d bar equation, and I'm going to save that as the letter A. A lot of people ask, well, why don't you save it as the letter D? Well, because a lot of times there's confusions when I look at a formula on what is D. Is it D or is it D bar? That sort of thing. Okay, that will get you to the standard deviation. I'll plug into there and I'll save the standard deviation as the letter S. And then I think everything else is known. It's worth noting that n is equal to 6. Okay, so let's go ahead and get this party started by finding our difference and our average. So we go to our calculator and make sure things are cleared out. As I said in the last video, make sure that when you enter these numbers, not only do you enter them properly, but don't mess with the order in which they come. The order in which they are is very vitally important. Okay, so let's go ahead and find our difference, which is x minus x2, aka list 1 minus list 2. Back to my main calculator here. So list 1 minus list 2. Okay, so those are our differences. So I take that list answer and store it as list 3. Okay, so that is now into list 3. We have our differences. Now we need to find our average. So we add them up and divide by the number of numbers. So we sum list 3. So we add them up and divide by the number of numbers, which is 6. Okay, that is our average. So I take that answer and I store it as the letter A. Okay, now I'm on to the standard deviation problem. If you need a breakdown of specifically how I do this, take a look at the previous video. But I'm going to get an answer to the numerator. I'm going to divide that by the denominator, and then I'm going to square root it. Okay, so I get this numerator first. So that's the sum, open, of D, which is list 3, minus D bar, which is the letter A, closed squared closed. Okay, so that is our top. I divide by the bottom, so divide by n minus 1, which is 5. And then I square root that. Okay, that is our standard deviation. I am going to store that as the letter S. And then obviously have to write it down because that's what the first question is asking for. Okay, in this next problem, very simple. Again, d bar minus s divided by the root of n. Most of those things are just straight up known. I have to remember that I need to make sure that I have this denominator in its own unique parentheses. If you have like the cool fraction thing where it writes it as a fraction in your calculator, then you really don't have to worry about that. So here we go. D bar, which is the average, divided by S, which is S, divided by the root of n, which is 6. Okay, this is our t value in this situation. Okay, degree of freedom, n minus 1, n was 6, so this is going to be 5. Now we're ready for our p-value. So our p-value, I create this big line so my work doesn't get kind of confused with the actual p-value, my actual answer. This is built on a t of negative 1.5119 and a degree of freedom of 5. Now, before I find this, I encourage you to look at the next question so you know what you're looking for. So I look at the alternate hypothesis. And what this alternate hypothesis is telling me is this is a two-tail. So when I look up that p-value on my paper, I need to make sure that I am looking at the two-tail area, not the one-tail area. Okay, I also notice that my alpha is eventually going to be 5%. So here I have a t of negative 1.5119, degree of freedom of 5. So take a look at the t-table for that. Okay, so we are looking at our t-table for this, the t-table. We're looking at the degree of freedom of 5, is that line. Looking for 1.5, 119. 1.5 falls in between those two right there. Again, this is a two-tail, so make sure you're looking at the two-tail area. Again, you have to take a look at that next problem to know what you're looking for. All right, so that is, well, what we get in this situation. So let's jot down those numbers here. Let's go back to our screen. So I looked up the t-value and it fell in between 1.476 and 1.699 on a two-tail list. That is 0.200 and 0.150. Those that's where it happens to fall. Okay, again, you have to look at the next problem for the alternate hypothesis to know what you're actually looking for. This one happens to be a two-tail area. Okay, speaking of two-tail areas, we have to make a sketch that's a two-tail with an alpha of 5%. Alpha of 5%. Okay, Now I need to put this this p-value on there. Now a lot of people, again, I know I mentioned it in a few videos, I think in the last chapter, where this technically goes. Does the line go to the on the right-hand side? Does it go on the left-hand side? And really, personally, I really don't mind as long as it ends up in the correct area. But very technically, where it goes is dependent upon the sign that is on either your Z or T. Okay, here the T happens to be negative. And so what this is it's positive if you're on the right-hand side, negative if you're on the left-hand side. So very technically, again, I don't really mind personally, but technically this is on the left-hand side. Okay, I'm looking up a value of 0.200 or what, either one, doesn't matter. They're both bigger. They're both bigger. So the p-value in this situation, I'll say is 0.150. I don't really mind which one to write down. Okay, so we have that on our paper, and so our p-value is larger. So this is the three-part process of breaking this interpretation down. Okay, so one, you draw the comparison of the p-value to the alpha. Here our p-value is greater than our alpha, which means do not reject H naught. So I don't know if we've done a problem like this before. So in essence, we do not reject H naught. So in essence, we're not quite accepting H naught, but we just can't prove the other thing. So here's what we're going to say. So in the world where we reject H naught, accept H1, that's the next step. We take H1, and H1 would be mu of D is not equal to 0, x1 minus x2 is not equal to 0, x1 is not equal to x2. Okay, that's what we would do in that situation. Here, we're not rejecting H naught. So what we're going to do here is we're in essence taking the answer that is H naught. And H naught says mu of D is equal to mu of D is equal to 0. Okay. Again, the thing to recall that mu of D is x1 minus x2. So this is x1 minus x2. That's what mu of D is, and that's ultimately equal to 0. Stuff down. Okay, so in our answer here, that implies that x1 is equal to x2. Okay, but this is one when you do not reject H naught. This is when we have to use a little bit fancy words. And the words that you use in this case is we are unable to determine a difference between. Okay, so let me type that down. It's a little smaller here. Oh, excuse me, we're unable to how do I write it down? Like, let me take a look at what I wrote on some of my answer keys, and that so I can be consistent. We're able to prove a difference between. Yeah, unable to prove a difference between x1 and x2. Okay. We're unable to prove a difference between. So there's probably a difference, but we can't prove it. So we're not saying that our initial thoughts were wrong. It's just we're unable to prove a difference. We're trying to prove a difference, and we're unable to. X1 and X2. So X1 was the typing speed of the new keyboard. And then I usually kind of use the word verse, so like the new verse, what, regular keyboard? Regular keyboard. So we're unable to prove a difference between the typing speed of the new keyboard versus the regular keyboard. There's probably a difference, but we just need to either change our sample or get more information, but we just can't prove that there is a difference right now. Okay. Again, if it was this alternate answer, then we would say the typing speed of the new keyboard is not equal to the typing speed of the regular keyboard. Again, stick to the symbols. Don't interject your own words. So we'd say that, yes, there is a difference. So the regular keyboard is not equal to the the new keyboard is not equal to the regular keyboard. Here, when it's the equal, when we do not reject a shot, we're unable to prove a difference between. We're unable to prove a difference between. Okay, let's go ahead and check out. Here we are with a gas additive. Let's remind the viewers of all of the different formulas. And then again, ultimately, what I need to create that'd be it. Okay, so I go ahead, clear out my calculator. So I'm just going to scroll through here again just to make sure. Okay, looks good to me. All right, so we go to our calculator and we make this difference, which is list 1 minus list 2. That will create a list that is our difference. So I take that list answer and I store it as list 3. Okay, so now that is list 3. Okay, now I need to find this average, so I sum up those differences and divide by the number of numbers, and I'm going to store that as my average, which is going to be the letter A. So I add them up. And divide by the number of numbers, in this case that's 10. That is my average, so I store that as the letter A. B bar is the average. Okay. Okay, here we go. So now I am on to the sample standard deviation. So I begin with that numerator. So that begins with the sum, open, open, D, which is list 3, minus D bar, which is the average, letter A, closed, squared, closed. That's the numerator. I divide by the denominator, which is n, 10, minus 1, so that's 9. I have to square root that. And that is what we get. Yep. Okay, so that is our standard deviation. I am going to store that as the letter S. But that's our standard deviation. That's our first answer. Okay, so let's go ahead and get our T from this. So we take the top, which is the average D bar, so that's A divided by, I have to put the denominator in its own unique parentheses, which happens to be S divided by the root of N, which in this case is 10. And that is our T, which is 4.7143. Oakley dokley. Oh, sorry. Degree of freedom is n minus 1, which is 9. Okay, now I find my p-value, and I don't want to get it twisted up with the work that I'm going to produce. So I have a t of 4.7143 and a degree of freedom of 9. Now, again, before I do this, take a glance at the next problem. And so this is a one tail, more specifically a right tail. This is a right tail with an alpha of 5%. Okay, so that is that. So when I look up this p-value, I don't need to look at that, the two tail area. More specifically, this is going to be the one tail area. All right, so 4.7143. Okay, so we take a look at our t-table for this one right here. Looking at the degree of freedom of 9 for 4.71. Wow, it's way up there. It's almost maxed out on the degree of freedom of 9 line there. So 7.1, it just fits in. If it were off the map, if it were like to the right of that, what you do is you just accept the closest value that you do have. So you're not going to have two values. You're just going to accept whatever value you can get. All right, so here we take a look at those and we look up for the one tail area, and that is our p-values up there. All right, so back to the work. So this fell in between 3.250 and 4.781. Looking up, that was in between 0.005 and 0.005. Two incredibly small numbers, you're most likely going to reject in this situation. Okay, this is a right tail. Again, I'm getting all of this from the next question. It's a right tail with an alpha of 5%. And as I was just got done mentioning, our p-values are incredibly small, so their distance is way short and fall into that rejection zone. Okay, our three-part answer here. We begin with the comparison of the p-value to the alpha. which means we reject H naught and accept H1. Okay, so we're taking the answer H1. H1 is saying mu of D is greater than 0. Mu of D is x1 minus x2. Thus, x1 is greater than x2. Right, so here we have a definitive result that x1 is greater than x2. Again, if it were the is equal to, then we would say we are unable to prove a difference between. We are unable to prove a difference between if it were the is equal to. However, this is greater than. So what is x1 and x2? X1 is the gas mileage, like gas mileage with the additive, and then x2 is without the additive. So the gas mileage okay, with the additive is greater than gas mileage without the additive. Okay, again, stay away from words like is better than, is like longer than, things like that. Stick to the symbols. So the gas mileage with the additive is greater than without the additive.